Okay, grade 7, this is your practice test number 1 for your December assessment. A couple parents had emailed me about when this test is. It's on Wednesday. It's not really a test, and it's not really an exam. The word we're going to use for this is an assessment. It is formative. It will not affect your mark, but it will have a good indication of the progress you are making this year in mathematics, okay? It's going to let me know how effective my teaching has been. It's going to let you know how effective your learning has been, and it's going to let your parents know how big a Christmas present they're going to give you, okay? The first 4 questions on the test, or no, first 6 questions are true, false. And the first one says 3/5 is greater than 0.6 repeating. Remember, I know we've talked about this quite a bit of times, but the greater than symbol will always be used when you are eating the larger number. So when I read this, I would say 3/5 is greater than 0.6 repeating. And the answer for this is false, and here's why. If I wanted to change 3/5 into a decimal, I would first have to create an equivalent fraction that has 10, 100, or 1,000. So when I look at this, I realize that I can make it into an equivalent fraction with a 10 denominator. In this case, it would be 6/10, which as a decimal is written as 0.6. So another way to think about this question is like this. And we know that 0.6 is really 0.6000000. And we know that 0.6 repeating is 0.666 to infinity. So therefore, this number is larger, and it is false. The second question says 10% of $402 is $40.20. When we have 10% of a number, we were asked to take the decimal, in this case, in $402, it's at the end, and move it one place to the left. So when I rethink about this as money, it's $40.20, which makes question number 2 a true statement. Question number 3 says 1 over 11 equals 0.09 with a bar above the 9. Well, if I take my calculator and change 1 over 11, I go 1 divided by 11 equals, and it says that it's 0.090909 forever, which means that actually in bar notation it's 0.09 with a bar above both the 0 and the 9, because that's the pattern that repeats. If it was this would be 0.099999, which is not what this number is here. So therefore the answer is false. Question 4 says 56 out of 114 is a greater number than 31 out of 65. In order to solve this, there's 2 ways we can do it. We could, if we wanted to, change both of these to equivalent fractions that have the same denominator and then compare them, but that would be crazy because your common denominator between 114 and 65 would be a crazy number. The easier way is to change them both to decimals using a calculator. So if I go 65 divided by 114, we know that's how we can change a fraction to a decimal. In this case, I get 0.49122 something, something, something. The next fraction, 31 divided by 65, changes it into 0.47692 something, something, something. So therefore, this number is larger than this number, and we can say that question 4, the answer is true. Question 5, when flipping 2 coins, the probability of flipping 2 different sides is 2 out of 4, or 50%. Now, probably most of you knew the answer before you actually made the table, but because you have to show your work, you probably made a table like this that would show the first event is heads and tails. That's the first coin. The second event is the heads and tails. That's the second coin. And you can clearly see from this table that there are 4 possible outcomes. Okay, so we have 4 possible outcomes right in here. This is our sample space of all the different combinations that we can have. This one is heads, heads. This one would be heads, tails. This would be tails, heads, and this one would be tails, tails. So the question is that we have different sides. These are 2 different sides, and these are 2 different sides, which means there are 2 chances out of 4 which would mean that you have a 50% probability, which means that question number 5 is a true statement. Question number 6 says 987,654,329 has 9 as a factor, which means you could divide it by 9 and not have a decimal, right? 9 is a factor. Well, our rule for divisibility is, so the divisibility rule is that if you add the digits together, so 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 and plus 1, if the sum of the digits of the number itself is a multiple of 9, then the number is divisible by 9. So here's how I did it. So 9 plus 1 I'm going to do first. That's 10. 8 plus 2 is another 10. That's 20. That's 30. That's 40. 45. So the sum of all the digits is 45. And 45 is a multiple of 9 because 9 times 5 is 45. So therefore the answer is true. That is divisible by 9. And if I take my calculator and divide it by 9, I get a non-decimal factor as well. So 109,739,369 is also a factor of that number. Question number 10 says, what is 10% of $84.50? Again, for 10%, we want to take our decimal and move it one place over, which would mean that 10% is $8.45. If you had that extra zero there, you have to realize that technically when we're talking about money, we don't use 3 decimal places, we use 2. But in some instances we do, like for example, if you buy gasoline, they will actually use 1/10 of a cent for gasoline because the price fluctuates. So there's so much volume of gas sold that 1/10 of a cent per liter is still a significant amount of money when you talk about the entire country buying gasoline. In the second one, we have 5% of $44. So for 5%, we need to find 10% first. So 10% would be $4.40 because I moved my decimal one place over. And 5% would be half of that, which means 5% is $2.20. Question 9, 1% of $465. 1% of that. For 1%, we know that our rule is to take the decimal, in this case at the end of it, and move it 2 places over. So 1% is $4.65. Question 10, 25% of $88. For 25%, we need to find half of half. So 50%, which is $44, half of that would be 25%, so therefore 25% is $22. Question 11, 50% of $38 is simply half of 38. In order to find half of that, half of $30 is $15. Half of $8 is $4. So half of 38 divided by 2 is going to be $19. Half of 38 is $19. 15% of $240. We need to find 10%, add it to 5%, and that will equal 15%. 10%, move the decimal one place over, will be $24. 5% is half of 10%, which is $12. The sum of those two is $36, which is 15%. Question 13 says 11% of $220. So we need 10% plus 1% to get 11%. 11%. 10% is $22 because I move it over one place. 1% would be $2.20 because I move it over 2 times. And therefore 11% would be $24.20. Question number 14 says 49% of $50. For this one, I'm going to find 50% and take away 1%. 50% of $50, we all know, is $25. 1%, I'd move my decimal 2 places over, would be 50 cents. So $25 take away 50 cents is $24.50, which is 49%. Second page, it says, what is 1/20th as a decimal? And I will also do question 16. So as a decimal and as a percent. Well, the first one I'm going to do is as a percent, because I know that 1/20th can be created into a percentage through an equivalent fraction. And I know that percentages are out of 100. And when I look at this setup, I know that I can multiply this by 5 and this by 5. And I get 5/100ths, right? Which is 5%. Now, as a decimal, I'm also going to use that to figure out my decimal because it's 5/100ths, which is 0/10ths and 5/100ths. For questions 17 and 18, I give you the decimal 0.2, and it says, what is the fraction and what is the percent? So for 0.2, this is 2/10ths, because I would read it as 2. So for 2/10ths, that is a fraction, but it's not in lowest terms, because 2/10ths, both the numerator and denominator share a factor of 2, which makes it, in lowest terms, 1/5. As a percentage, I'm going to use this fraction to help me get there. So 2/10 is equivalent to how many hundredths? I would multiply my denominator by 10 and my numerator, which means as a percentage, 0.2 is 20%. Questions 19 and 20 say, what is 8% as a fraction and as a decimal? So as a fraction, that's pretty easy. 8% is simply 8/100. The only problem is that's not lowest terms. The largest common factor both 8 and 100 share is 4, which means I could divide both numerator and denominator by 4 to get 2/25. As a decimal, I'm going to use this one to give me my decimal, because it says 8/100ths, which is 0/10ths and 8/100ths. And that's what 8% would be as a decimal. Question 21 says, what is the probability of a sum of 7 when 2 dice are rolled? And write it as an approximate percent. So for this one, I need to make a table. So when I make my table of values for the 2 dice, I have 1 to 6 in the first, 1 to 6 in the second. Sum of 7 means you add the two numbers together and you get 7. So a 1 and a 6 would be 7, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, and a 6 and a 1. Those would all be combinations of the dice that would leave you with a 7 sum. So that means out of the 36 possible outcomes, 6 of them are 7. Which, if I take my 6 divided by 36 and change that into a decimal, I would get 0.16 repeating, which is approximately 16.7%. Or if you wanted to round it to just one approximately, sure, 17%. If you wanted to round to the nearest percent. Question number 22 says, what is 1/9 as a decimal? So for this one, if you didn't have a calculator, you would have to go 1 divided by 9. And you say, how many 9s in 1? You can't do it. So you put some zeros down here and say, how many 1s in 10? You say there's one of them. I'd subtract, you get 1. Bring down your 0. How many 9s in 10? There's 1. Subtract, you get 1. Bring down your 0. You go 1. And you would do this forever. So therefore, you realize that as a decimal, it's 0.1 repeating to infinity. You could also do that with a calculator by simply going 1 divided by 9, and it would tell you the exact same thing. Question number 23 is a fraction question. It says, what is 1/6 plus 2/6? To show your work, you really, since you have a common denominator, you simply have to add your numerators, which would leave you with 3/6, which in lowest terms is 1/2. In question 24, you have 5/8, take away 3/8. You have a common denominator, so your rule is just subtract your numerators and keep your denominator. You get 2/8, which in lowest terms is 1/4. For question 25, 3/4 plus 2/5. You do not have a common denominator, so you have to create two equivalent fractions that share a common denominator. The first multiple that 4 and 5 share is 20. So to create the equivalent fraction, 15/20 has the same value as 3/4. 8/20 has the same value as 8/20 has the same value as 2/5. Add those together, you would get 23/20, which is 1 and 3/20 as a mixed fraction. Oh, I was supposed to subtract it, wasn't I? No, add them? I was adding them. That's good. Question number 26 says 1 3/4. Take away 7/8. So when you were subtracting with mixed fractions, if you're still one of those few people that are holdouts for I like the borrowing method, fine, go ahead and borrow until the cows come home. But if you are semi-intelligent and realize that it's much easier to use improper fractions than it is mixed, the first thing I'm going to do is change 1 3/4 to 7/4. And then I'm going to say, you know what, this one looks much easier. So now I'm simply going to change common denominators of 8. This would be 14/8 and 7/8. Subtract your numerators and keep your denominator. My answer will be 7/8. Okay, so the answer for question number 26 is 7/8. Question 27 is 1 2/5 plus 3/5, 3/10, excuse me. So because you're adding, you can simply do 1 2/5 plus 3/10. Common denominator is 10. It's be 4/10 plus 3/10, which is 7/10. And on the test, many people forgot what? To bring back in your whole number, which is 1. So your answer is 1 7/10. Question number 28 is 2 1/5. Take away 3/4. Again, you have subtraction that involves mixed fractions. Intelligent people don't borrow. So you'd have 11/5. Take away 3/4. Your common denominator will be 20. You'll have 44/20. Take away 15/20, which is 44 take away 15 over 20, which is 29 over 20, which is improper. 1 9/20 is your final. Question 29, you have tree and a tent. Take away 1 1/2. You're dealing with subtraction of two mixed fractions. Convert them both into improper. Reevaluate the denominators. Realize the first multiple both 10 and 2 will share is 10. If you use 20, it'll still work. It just means you have to reduce your answer. 31/10 doesn't change, but 3/2 will change to 15/10. Subtract your numerators, keep your denominator. You end up with 16/10, which is 1 6/10, which in lowest terms is 1 3/5. And your last question, question 30, says 1/2 plus 3/5. Take away 9/10 plus 1/20 plus 1/4. So the easiest way to do this is to think of all of these fractions that would share a multiple, the denominators. The multiple that all the denominators in all 5 of these fractions share is the denominator of 20. So you can make equivalent fractions with 20 as your denominator. This will be 10/20. This will be 12/20. This will be 18/20. This will be 1/20. And this will be 5/20. Then, if you keep your denominator, you can add, subtract, add, and add those numerators. This is 22. 22 take away 18 is 4. 4 plus 1 is 5. 5 plus 5 is 10. So the numerator simplifies to be 10. And 10/20 in lowest terms is 1/2.